The Ultimate Factoring Series, Lesson Number 4, The Sum of Cubes. I would strongly encourage you, if you haven't already, to make sure you look at Lesson Number 3, The Difference of Cubes. So unlike squares where we can only do the difference, with cubes we can do both the difference and the sum. And you can see, if you watch the other video or you're familiar with the difference of cubes, the formulas are very similar for difference of cubes and sum of cubes. In fact, the only thing that's different is where the signs go. So with the sum of cubes, a cubed plus b cubed, we have that equal to a plus b times a squared minus ab plus b squared. So if we call a the first one, and just a, I'm not talking about a cubed, just a, we can call that the first one. We can call b the second one. Then we use the same rhyme that I used in the previous lesson with difference of cubes. Actually, the exact same one works. First one, second one, first one squared, first one times the second one squared. The first sign is the same, the second one is not, the last one's always positive, and that's what you got. So if you learned this same rhyme with me in the previous lesson, then you can remember the same one for this. First one squared, first one times the second one squared. The first sign's the same, the second one's not, the last one's always positive, so that's what you've got. So just a reminder, a refresher on the perfect cubes. The numbers would be 1, 8, 27, 64, and 125, and so on, and that's because 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. And then the variables there are all cubed, x to the 6th, x to the 9th, and so on. And then 8x to the 6th, 64y to the 9th, 125x cubed, y to the 6th. So just a couple reminders, when it comes to the variables, as long as their exponent is divisible by 3, they are a perfect cube. And when you have numbers and variables mixed, like the last line, both the number and the variable have to be cubed. In other words, 8 has to be perfect cubed and x to the 6th, 64 and y to the 9th, 125 and x cubed and y to the 6th. If they're not all cubes, then the whole term is not a perfect cube. For example, if I were to pick 17 x cubed, well, x cubed is a perfect cube, but 17 is not. That means this term as a whole is not a perfect cube. So first example, x cubed plus 125. Again, we want to figure out exactly what's being cubed. So x is being cubed. And then you need to think what number cubed would give you 125, or what's the cube root of 125? That would be 5. So x and 5 are both being cubed. And we're doing the sum of cubes because we're adding, so that's the sum. And we know this will always be binomial times trinomial, in other words, 2 terms times 3 terms. So we will call x the first one and 5 the second one. First one, second one squared, first one times the second one squared. 5 squared is 25. The first sign is the same, the second one is not. The last one's always positive, so that's what you've got. First one squared. First one times the second one, last one squared. The first sign's the same, the second one's not. The last one's always positive, so that's what you've got. Again, if you would like to check your answer, you can multiply that entire thing out. You have to do it with a lot of distributing. Every term in the first set of parentheses has to be multiplied by every term in the second parentheses. But you can do that. You can combine all the like terms And if you've done everything correctly, you should get x cubed plus 5 cubed, or x cubed plus 125 right back. Okay, now let's move on to 27y cubed plus x to the 9th. So we need to think what is actually being cubed. So what cubed gives me 27, or what is the cube root of 27? That's 3. And the cube root of y cubed is just y. So 3y is being cubed, giving us 27y cubed. And then what cubed gives you x to the 9th, or what's the cube root of x to the 9th? And that would be x cubed. Okay, I'm going to give myself a little more room here. This one will probably be one that I do in 2 steps, just to make sure I get all the simplifying correct. So my first one here is 3y. My second one here is x cubed. So let's set up parentheses here. Binomial times trinomial. First one, second one. First one squared. First one times the second one squared. The first sign is the same, the second one is not. The last one's always positive, so that's what you've got. So let's simplify that now. First term, or first set of parentheses is fine. No simplifying needed there. 3y squared. Remember, squared means times itself, so we're doing 3y times 3y, which is going to give us 9y squared. You have to square both the 3, giving you 9, and the y, giving you y squared. Then we'll have 3x cubed y. Just so you know, in that middle term, when you're multiplying, you can technically write things in any order, but it's kind of math etiquette to always put the coefficient or the number first and then go in alphabetical order. So x would come before y in the alphabet, so I put the x cubed before the y. And then x cubed squared would be x to the 6th, because I have to multiply those exponents together. Final example for sum of cubes. We have 8x cubed plus 64y to the 12th. Again, we know it's the sum of cubes because it's adding. We need to figure out what is being cubed. Well, the cube root of 8 is 2. The cube root of x cubed is x. So 2x cubed is the same thing as 8x cubed. It's the same as 2x times 2x times 2x. The cube root of 64 is 4. The cube root of y to the 12th is y to the 4th. Okay, again, I'm probably going to do this one in 2 steps, make sure I get all the simplifying correct. So binomial times trinomial. My first one this time is 2x. My second one this time, oops, sorry, I forgot my cubed here. My second one this time is 4y to the 4th. So first one, second one, first one squared. First one times the second one squared. My first sign is the same, the second one is not, the last one's always positive, and that's what you've got. We have it now, but we need to simplify. First set of parentheses is already good to go. My second set, 2x squared, is 4x squared. Remember to square both the 2 and the x. Okay, next I have 2 times 4, which is 8, and then xy to the 4th. And then 4y to the 4th squared will give me 16y to the 8th, because 4 squared is 16. And then y to the 4th squared, you multiply the exponents together and you get to the 8th.